even as we are looking at equations today, we focus much on radical equations. What are radical equations? We understood what an equation are. We've talked about absolute value equations so far, and now we're looking at radical equations. What is a radical equation? By definition, when we look at radical equations, we're talking about equations involving roots. Equations involving roots. Now, when it comes to equations involving roots, we have to understand that there are different kinds of roots. We can have, for example, a square root. We can have, for example, a cube root. We can have, for example, the fourth root, and so forth and so forth. So all these equations which involves different kinds of roots are regarded to be in the category of radical equations. So now, when it comes to solving radical equations, we have to understand, or maybe we have to be able to refer to the video we made on surds and radicals. So if you've not gone through surds and radicals, the video we made, please find time and look at that video we made on surds and radicals, where you're supposed to be able to know how to simplify surds, how to simplify radicals, how to some of the properties and the rules involving surds and radicals. So because we'll be embracing most of them when it comes to solving equations. So now, all these formats, which involve such roots, are basically called radical equations. So we have to understand that if I was to write root of x, this is the same as saying writing x power 1 over 2. So most necessarily what is happening here is that sometimes an equation can be written using the root, or maybe that root can be expressed as a power, such that the square root of x can still be written as x power 1 over 2, which of them is still the same thing. So all these can be understood when you understand the rules of indices as well as some of the rules of radicals. The same is happening if I was to write the cube root of x. This is the same as saying x power 1 over 3. So when I'm simply saying x power 1 over 3, I can still relate to say, oh, I'm talking about the cube root of x. So all these are talking about radical equations. So any format or any equation which involves roots is specifically talking about radical equations. Now look at this. Let's talk about maybe some of the one or two examples. For example, I can simply say solve the following equations. A, where we're simply saying the square root of 2x plus 1 to be equal to 4. B, we're talking about the cube root of 3x plus 1 is equal to 2. So solve these two equations. So now, what are we looking at? We're looking at radical equations, or equations which involve roots. As you can see on A here, there is a form of the square root of a certain expression, and on B there is a form of a cube root of a certain expression which is equal to a certain constant number. So now the question is, how do we solve radical equations? How do we solve radical equations? So when it comes to solving of radical equations, what is the rule which we are trying to follow? So the thing is, first, your aim is to delete. How do you spell delete? Delete the radical. The first aim is to delete the radical. So how is this radical deleted? By raising the expression to an appropriate power. To an appropriate. I'm sure you can bear with me spellings. So appropriate power. For example, if I want to delete a square root, deleting a square root means that I have to raise my expression. So if it says square root of x is equals to maybe 2, for me to find this value of x, I have to raise my expression to power 2 for this square root to be deleted. Remember, this square root is the same as saying power 1 over 2. So the only way a 1 over 2 can be deleted is to multiply it or maybe raise it to a power 2, so that this and this would cancel out and I can still remain with my x to be equal to the power 4. My x to be equal to 4. So now, this raising of the expression which we are talking about, it means that whatsoever expression you raise it to a certain power, you do it also on your right hand side. You don't only do it individually on the left hand side where the radical is, no, but you're simply saying the entire expression from the left hand side, if it is squared, even my right hand side as well should be squared. It's equal opportunities for all, because remember, we're talking about this is an equation, an equal to sign, and for us to have something which is equal to, we're simply not supposed to change the meaning. So if I just square my left hand side, it means that I'm trying to, by all means, I'm trying to change the meaning of this equation when I squaring the other side. So if I square the left hand side, even the right hand side as well should be squared. So what are we simply saying? Our first aim is to make sure that the radical is raised to an appropriate power. If it is a square root, I will raise the expression to a power 2. If it was a cube root, I would have raised the expression to a power 3. If it was a fourth root, I will raise the expression to a power 4. So every time I want to derivate a certain radical, always raise the expression to a certain appropriate power. So this is what is happening here. If I look at the first part, I have root of 2x plus 1 is equal to 4. So now I'm dealing with a square root here. So it means that the first aim should be able to make sure that the radical is deleted. So this can only be deleted by raising power 2. So whatsoever I do to my left hand side, even my right hand side should be the same. So squaring that side and squaring that side. Squaring my left hand side deletes my radical. I'm going to remain with the 2x plus 1 to be equal to squaring my right hand side. 4 squared, I'm going to remain with 16. So that finding the value of x now to be 2x is equal to 16 minus 1 over 2 over 2, so that the value of x can be equal to 15 over 2 as the value of x. The same is happening with our b part. Our b part says that the cube root of 3x plus 1 to be equal to 2. I want to delete the radical. The radical can only be deleted by raising power 3. I'm raising power 3 because I'm dealing with the cube root. So raise the power 3 as well on my right hand side, so that we can have 3x plus 1 to be equal to 8. So that by the end of the night we can have 3x is equals to 8 minus 1 over 3 over 3, and the expression will now be, the variable x will now be equivalent to be 7 over 3. So this is how basically I'll be able to handle radical equations. Okay, now let's look at the second part, or the second example. So now, even as when you look at a newborn baby, compare first to milking, then it upgrades from there. So we've just added some spices here, but the rest, the same concept, it's still the same concept. We're still solving radical equations here, no matter what happens, what is happening here, but still radical equations. So remember, the first aim, always aim first of all to delete the radical. So your aim is to make sure that the radicals are deleted, and then so that you can continue and solve the variable. Solve for the variable. So a here is also very much simple, where we're just looking at the square root of 2x plus 5 plus 3 to be equal to 0. The square root of 2x plus 5 plus 3 is equal to 0. So what do I do? So my first step, I have to make sure that my radical is to my left hand side, is made as the subject. So I can simply say make the radical the subject, the expression with the radical the subject. So if I can make the expression with the radical the subject, this is going to become 2x plus 5 to be equal to negative 3. Next, I go to my usual step of making sure that my radical is deleted. So how can I delete this radical? This is just as good as squaring both sides. So squaring both sides, the radical here is deleted. I will remain with the 2x plus 5. This is negative 3 squared. This is not just 3 squared, but negative 3 in bracket and squared. Remember, we squared both expressions, the left side and the right side. So it would be very wrong for you to write a negative 9. No wonder what is happening here. We're writing the whole negative 3 squared so that we can have positive 9. So that by the end of the night, we can have 2x is equals to 9 minus a 5 over 2 over 2, and the value of our x will be equal to 4 over 2, which is equal to a 2. So from the first expression, we are being told that 2x plus 5 plus 3, we have our value of x, which can be inserted here to be equal to a 2. As simple as that. So this is the simplest among these three. Actually, everything is simple here. Now let's look at the B part. So we're looking at B now. This B says the square root of x plus 5 to be equal to the square root of 2x minus 5. So now what can you observe on this radical equation? Both sides, they are radicals. Both sides, they are radicals. So it is just as good as when the sum both sides, we're still dealing with a square root. So it's just as good as squaring both sides to make sure that the radical is deleted, so that I can have x plus 5 to be equal to 2x minus 5. And then from there, we just look at the issue of like terms, where we're talking about x minus 2x to be equal to negative 5 minus 5. X minus 2x, I'm having a negative x, negative 10, over negative, or other than simply say multiply both sides by negative 1, so that we can have our x to be equal to positive 10. So this will be the value of x for the second expression. Okay, so we're looking at the third one. So the third one, you have to be very careful there as well. So I've been told to say root of t minus 2 plus a 2 is equal to root of 2t plus a 3. Be very observant here. This 2 is not in the root. This 2 is outside the root. So we have this as our radical and that as well as our radical. Very important. So number one, remember this usual step. We always make sure that our expression should be raised to an appropriate power for some radicals to be deleted. We are still dealing with roots, so the only way these roots can be deleted is to raise both sides of the expression power 2. Now, take note here, I've not raised each term, but I've raised the whole expression. It wasn't necessarily by initial whereby I raised this power 2, but I had to raise the whole left hand side to a power 2 and the whole right hand side to a power 2. So that, what does this mean? The power 2 on my left hand side means that I have root of t minus 2 plus 2 being multiplied twice. And my right hand side is just as good as these roots deleting themselves, so that I can have 2t plus a 3. First step handled. So the next thing, you can observe that my right hand side, the root has been deleted. So the issue is me working on my left hand side. Let us simplify our left hand side. Now make sure when simplifying this, you're very much careful and be able to observe the properties of surds and radicals there, where you have to know how to multiply surds and or maybe radicals in this case. So breaking this bracket is just as good as this multiplying throughout and these two multiplying throughout. So here we have this multiplied by that, so which is the root of root of t minus 2 multiplied by root of t minus 2. It is being brought from the concept of us saying root of a multiplied by root of a, which is just the same as saying a. Okay? So now, the root of t minus 2 and t minus 2, this is more like our a. Inside here is our a because it's identical, it's the same value inside contained in that root. So multiplying itself, the radical is yeah. So as I was saying, the t minus 2 is more like the same value here, just as I indicated. Root of a minus multiplied by root of a is equal to a. You can find these properties from a video we made on sides and radicals. So there's a video we made on sides and radicals. Follow that video and be able to understand most of the properties which involve simplification of sides and simplification of radicals. So what are we simply saying here? We're being told that this multiplied by that, t minus 2 is more like our a. So the radical deletes. I'm going to remain with the t minus 2. The radical is gone. And then I continue with the root of t minus 2 multiplied by 2. This will be positive 2 root of t minus 2. I'm done with this guy. I go to my 2. My 2 multiplies throughout. This time that will be positive 2 root of t minus 2. The 2 multiplied by 2, I'm going to have positive 4 to be equal to 2t plus a 3. Okay, so now we can continue by looking at like terms together. Now, this is 2 root t minus 2 and 2 root t minus 2. It is more like I'm looking at 2x plus 2x because these two are identical. So 2x plus 2x, we know that 2x plus 2x is basically more like 2 of the x's added together, we're going to have 4 x's. So these two here, I'm going to have something to do with a 4 root t minus a 2. Okay? So that we can have 4 minus a 2, which are like terms. I'm going to have positive what? I'm going to have a positive 2. And this t will maintain. This will be t, this is a positive, like that. So I've just handled out all like terms in my left hand side. So I'm going to remain with a t, negative 2 plus that which is positive 2, but this plus that which is 4t minus root 2. 4 root t minus 2. My right hand side still remains the same, 2t plus a 3. So now, next, we still have a radical. Now, at least the first thing has been done where at least we've eliminated one radical, but we still have another radical in this expression. So we're going to raise everything on our right hand side and remain with the radical on the left hand side. So I'm going to remain with the 4 root t minus 2 is equal to 2t, which is this one. When this t comes to the other side, it becomes minus a t. I have a plus 3. When this 2 comes this side, it becomes minus a 2. So that we can have 4 root t minus 2 is equal to t plus 1. So what is happening here now? I have my radical on my left hand side. We continue the same process where we simply say that we have to make sure that a radical is deleted. So how do I delete this radical? We raise this expression to a power 2 and raise this expression to a power 2. So that this and that I'm going to have 16. This and that I'm going to have t minus 2. Where is this coming from? Properties of indices and radicals. We mentioned that if we have a multiplied by b squared, this square is for both the a and this square is for both the b. So we can write as a squared, b squared. Or if we had the root of a multiplied by b, this is the same as saying root of a multiplied by root of b. This as well is found in the video we've mentioned. So locate the sides and radical video which we made last time. At least you can be able to relate where these radical properties are coming from. So this squared is for both the 4 and this squared is for both this guy. So at 4 squared I'm going to have 16, but this squared will make the radical cancel. I'm going to have t minus 2t. Remember, what have I done? I've indicated this is a bracket. It is a multiplication. So this 4 multiplied by the outcome of this is multiplied by this outcome, which is t minus 2, to be equal to, this is squared, broken down, t times t, I'm going to have t squared, t times 1, I'm going to have positive t, 1 times t, I'm going to have positive t, 1 times 1, I'm going to have 1. And breaking these brackets, I'm going to have 16t minus 32 to be equal to t squared plus 2t plus 1. So I'm sure you can be able to relate what is happening here. We're trying to form something like a quadratic equation. Remember, quadratic always gives us about 2 values of t's. So everything can go on the other side, where you can have t squared plus 2t minus 16t plus 1 plus 32 should be equal to a 0. Now let me erase my other part of. So as you made the like terms, everything, what did we end up with? We had t squared plus 2t minus 16t plus 1 plus 32 to be equal to 0. Now cleaning everything up, we have t squared, this minus that, we have negative 14t, this and that, we have 33. Which is equal to 0. Can confirm, I'm human. So from there, this is a quadratic. I'm sure using the factorization can work, where we know that the product is positive 33, the sum is negative 14, and the factors should be 11 and 3. Both of them should be negative. So therefore we can have t squared minus 11t minus 3t plus 33 to be equal to 0, so that we can have t squared. We can now factor out by pairs. This will be t, open bracket, t minus 11. This is negative 3, t minus 11 to be equal to 0. We can have t minus 11 and we can have t minus 3 to be equal to 0. Therefore, t minus 11 can be equal to 0, or t minus 3 can be equal to 0, having the value for t to be equal to 11, or having the value for t to be equal to positive 3. These are the two values of t which will satisfy our equation, which is a radical one. Okay, so let's look at the last question and then we can call it a night. So we have, so for x, where x squared minus x minus 22 in brackets power 4 over 3 is equal to 16. So how do we find the value of x there? So there, number one, this was supposed to have, it's something need to click to say this is also under radical equations. Remember what I said in the first phase, to say we can have the square root of x. The square root of x can still be written as x power 1 over 2. If I had the cube root of x, this can be written as x power 1 over 3. So now, you can have situations whereby you have x squared and we have the cube root like this. So how can I write this? This is the same as x power 2 over 3. So what are we simply saying? When I have x power n over m, this is the same as m here, which is the denominator, this is the root, and n, which is the numerator, this is the power. So this power can still be written here, or it can still be written in this format. Both of them is still correct, no harm. Wherever you put it, either at x here or after rooting the x and then you raise the power n, is still the same. So this is what is happening here. For the fact that this is raised to a power of a fraction, it means that this is a radical which is being experienced there. What kind of a radical? It's a cube root. Okay? So now, the easy way to solve this, we're simply saying m to delete this radical. How do I delete this radical in this case? This is a fraction. So deleting this fraction is just as good as multiplying by the reciprocal of that. So this can be as good as saying x squared minus x minus 22 power 4 over 3 multiplying by the reciprocal, which is 3 over 4. Now, whatsoever you do to your left hand side should be done to your right hand side. So this is 16 power 3 over 4. So that this and that can go, this and that can go, this is power 1. So I'll remain with x squared minus x minus 22 to be equal to what? What did you say about a power? This is a root and this is a power. This is a root and this is a power. So I'm simply talking about the fourth root of 16, your answer raised to a power 3. What is the fourth root of 16? The fourth root of 16, if I'm not mistaken, is a 2. Because 2 multiplied by 2 multiplied by 2 multiplied by 2, I believe it's a 16. This is 8, this is 8, 8 times. Sorry, this is 4, this is 4, 4 times 4, this is 16. Yeah. So the fourth root of 16 is basically a 2. So the answer should be raised to a power what? 3. So I have x squared minus x minus 22 to be equal to what? X squared minus x minus 22 to be equal to 8. So this is still a quadratic. I'm looking at x squared minus x minus 22 to be equal to 8. So we're solving this quadratic, which will be in the form of x squared minus x minus 22 minus 8 to be equal to a 0. So what are we having? This is a quadratic in the form of x squared minus x minus 22 minus 8. This is the same as minus the 30, which is equal to 0. So these are this is a quadratic equation where you will now be able to take it up from here and be able to solve for the value of x. So what I'm going to do, I'm not going to finish it because I understand that you people have knowledge and like quadratic equations. So finish it up for me and be able to send me the values of x. What is the value of x? Because we know that the value of x should be 2 because this is a quadratic form. So send your solution to my WhatsApp line as usual, the way you've been dealing with every time. So our homework for today will just be basically finishing up this task. Thank you very much and have a blessed day.